Okay, good morning and happy Wednesday, everybody. So, before we proceed, I would just like you to be reminded of our rules for today. So, Ola, I hope you will obey, listen, and apply. So, follow directions quickly, raise your hand for permission to speak, make a sign before you leave your seat, make everyone happy, and make smart choices. So, let's see. If you know some of the multiplication computation and try to do this on your own using a paper, pencil, or a whiteboard and a marker. So let's try. First one, multiply these numbers. What is 3 times 3? Okay, 3 times 3, the answer must be 9. Next one. Multiply these numbers. Go. 6 times 6. Answer is 36. Third one. Go. 8 times 8. Let's see. Correct answer is 64. Next item. What is 10 times 10? Correct answer is 100. Next one. This will be our last item. Go. 11 times 11. So answer is 121. Okay, so I hope you got all of this multiplication problem correctly because we will be using this and applying this in our lesson for today. And this is determining square roots of perfect squares. Okay, so what is a perfect square? If you have heard it, well, we can apply it also and we can use this and determine this term using decimals. But before that, a perfect square are numbers which can complete a square shape without having any extra pieces left over. So if you will go to your Google Classroom, there will be a Desmos activity task that you can work on. So let's try it. Okay. So here, so I have here the Desmos activity, the square tag. So for those who will open Google Classroom, just click the Desmos activity for today, and this is our task to work on, the square tag. Okay, for this square tangle, you will be using this one. Okay, so how will you make use of this? And how will this help in our lesson for today? So allow me to annotate. Okay. So in class, I will be giving something like this. Okay, this one. So if you cannot see it, okay. So this kind of paper. So I don't know if you see it clearly or it's blurry. But anyway, this one is called Making Perfect Squares chart. And in the chart, there will be the length here on this side. Okay, so there will be length on this side of the table, and then there's another row, and that is for the area. Okay. So I repeat, there will be a table in this paper. Okay. So what you can do is just to make use of this given here, the side length and the area, for you to be able to complete the chart. Okay. So the side length is in here and the area is in here. So kindly check that. So how will we use the Desmos? So you just need to navigate this circle, this one, this red point, until you go to 15, until 15 length, okay, length of 15. So you can start with 1. So if you have 1 as your side length, the area is also 1. I repeat, if you have this length 1, okay, I put that red point until 1 only. So your length is 1, your area is 1 also. Okay. So let's see. So I put 1 here in the length. 1, and then area is also 1. So you can see that, right? Next. If I will move this again, okay, the length will change and that became 2. We put 2 here, and then the area changes also and it became 4. Okay, so until move up and up, you will have your 3. From here, move it, it became 3. So take a look here again, and it says there, the length is 3. So 3 here. And then the area there is 9. Okay, let's do it one more time. I'll have until 4. So go back here, this one again. Side length here is 4. And the area is 16. Okay, so as you can see, these are only few. This is not done yet. You can have until 15. You can do it on your own. Okay, so 1, 2, 3, 4, 5 until 15 for this length. And then for the area, make sure you will be looking here at this side, that side, so you can get the correct area for each number. Okay, so that's it. That's how you will work on this Desmos until screen 2 only. Right after that, you can turn this in the Google Classroom and you're done. Nothing to do anymore with this Desmos. Okay, so when you complete the chart, when you're done working on this, there is just one question that I want you to ponder on. Okay, let me stop share. Let me share my screen once more. Okay. So there are, okay, this is how you see it a while ago. So if you have a length of 1, the area of the square is 1. If you have a length of 2, the area of the square from your Desmos is 4. If you have a length of 3, the area of the square is 9. Okay, and moving on, if you have a length of 4, the area is 16. If you have 5, the area is 25. Okay, if you have an area of 6, a length of 6, the area is 36. And if you have a length of 7, the area is 49. So for those who are not here in our class, you may work on this chart. You may create your own first. And then when you come back to school, I will give you this paper so for you to complete this one. Okay, so this is how it looks like. Make sure your length will reach up until 15. And then don't forget the corresponding area here. Okay, put it somewhere. Make sure to complete this. Okay, so what can you observe? What can you observe from the length in relation to this area? So if you will observe this correctly and properly, the area is actually the length when multiplied to itself. Okay, I repeat, the area is actually the length when you multiply the length to itself. So from here, that's actually 1 times 1. That's why we got an area of 1. Isn't it? Okay. So I'll put it here. The area is actually the length. 1 times 1, multiplying the length to itself. And that is 1 times 1. What else? The second one, if you look at the second one, it's the same thing. That's actually 2 times 2. Right? The third one is also the same. That is actually 3 times 3. Correct? And it goes on and on and on. Here, that's 4 times 4, 525. So on 525, that's actually 5 times 5. For 36, that's 6 times 6. For 49, that's 7 times 7. So meaning, even if you don't use the Desmos navigation screen, you can get the area, just multiply the length itself. Okay, I hope you get that. So if you want to reach up until beyond 15, you can also do the same: 16 times 16, 17 times 17, 18 times 18, 19 times 19, and 20 times 20. That is how you do it when you get the area. So how is this related to our lesson? Well, this one actually tells you that this area can make a perfect square. So this side of the table or chart makes a perfect square. Okay, so if you will ask what are the different perfect squares, just look at this column for the area of the squares. And here are the numbers that are a perfect square. We have 1, 4, 9, 16, 25, 36, 49. And then you have more. We have 64, 81, 100, until you move on to until 20. Okay, I can give you until 20. So where are those? Okay. So this is what I'm telling you a while ago. For you to calculate the values of squares of 1 to 20, you may multiply it by itself. So for example, the square of 11, it is 11 times 11, so you'll get a perfect square of 121. Okay, and it gives you the square of the number 11. So here are the rest of the perfect squares. Okay, here, these are perfect squares. So for you to know, perfect square is actually squaring the number. Okay, so 1 squared, that's 1. So 1 is a perfect square. 2 squared, that's 4. So that is also a perfect square. 3 squared, that's 9. So that's also a perfect square. So these are from 1 to 10. So from 11 to 20, we have these numbers, and these are also perfect squares. Okay, so for example, in 12 squared, that's 144, so that's a perfect square. 16 squared, that's 256, so that's also a perfect square. Going on and on, we have 19 squared, so 361 is a perfect square. 20 squared, so 400 is a perfect square. So if you take a look at those columns, so you can see the different perfect squares. Okay, so I hope that makes sense. So if in case you cannot remember or memorize this one, you can just always make use of multiplication by just multiplying the number to itself, and you will get the perfect square right away. Okay. moving on. So do you now know what a perfect square is? So I hope yes, and it is easy already. So let's move on to square root. Well, square root is the exact opposite of perfect squares. Square root is the exact opposite of perfect squares. They usually look like a check mark or the radical sign with a line on top. So let me draw it here so you will see. So something like this. So you will be encountering this one and you call that a radical sign, but you read it as square root. Okay, so some of you may have encountered like, what is the square root of 36, right? If you have the radical sign, there's a number inside, square root of 81. So these are the things that you may be encountering soon, and you will be solving for those square roots. Okay, so square roots are two identical numbers when multiplied together that forms a number. Okay, so no need for Desmos. So how do we deal with square root? If you will go back to your table a while ago, so allow me to just move this and go to the table that we worked on, this one. And allow me to rewrite everything that we had a while ago. This one, this is 1, this is 4, this is 2, so okay, 3, 4. Okay, give me until there. So 9, 16. Okay, so a while ago, I told you that this area of the square are actually perfect squares. So this side of this chart are all perfect squares, the area of the square. So square root is the other way around. If that gives you the perfect square, the other side gives you the square root. Okay, and that gives you the square root. So if you want to know how to work on this, for example, I ask you, what is the square root of 1? So just look at the other column, it tells you the answer. So square root of 1, square root of 1, it will give you 1. So that's the square root. What is the square root of 4? It will give you 2. The square root of 9, it will give you 3. The square root of 16, it will give you the answer 4. Okay? So what you need to do is just to think of a number that when you multiply to itself, you will get the number inside the radicals. So another one, for example, 36. So for you to get the square root, you may think of a number that when you multiply to itself, it will give you this number, 36. So the answer there is 6. So the square root of 36 is 6. Another one, square root of 64. So what number, when you multiply to itself, you will get a 64. So the answer there is 8. So that is the square root. So if you will complete the chart, you will be seeing all of the lengths or your square root and all of the area of the square as your perfect square. So that is how related each of those things are. Okay. So if you will go back here, so it's in the Google Classroom, this one, the notes. So these are the square roots, everything on the left. Okay, allow me to give you, okay, square root here, square root, so you can have like an idea. And then the other side here are perfect squares, and there's perfect squares too. Okay, that's how you work on it. So if I ask you what is the square root of 100, the answer is 10. Square root of 289, the answer is 7. The square root of 169, the answer is 13. Square root of 400, the answer is 20. Square root of 225, the answer is 50. So everything is there. Okay? So I don't need you to memorize everything. So what you just need to do is to practice on multiplication so you know how to get the correct perfect squares. Okay, and then if it is the other way around, if you need to get the square root, you may also make use of multiplication by thinking first of the number, then multiply it, and then once you get the number inside that radical sign, then you'll have the correct square root. Okay, so there, let's practice. So find the square root of 64. Can I give you 5 counts? 5, 4, 3, 2, and 1. Answer is equal to 8. Good job. Next, square root of 81. 5, 4, 3, 2, and 1. Answer is 9. Good job. I hope you're doing it right. Next, square root of 169. 5, 4, 3, 2, and 1. The answer is 13. Next one, square root of 256. 5, 4, 3, 2, and 1. The answer is 16. And the last one, square root of 361. 5, 4, 3, 2, and 1. The answer is 19. Okay, so if you need some help, you just comment in our Google Classroom, comment down below. If you're still in one, you need lots of help, teacher would like to help you one-on-one, okay, I give you that. If 2, you still have some questions, just tell me. 3, you can do this task independently, and that's a great job. And 4, if you can teach others this new skill, why not? You can help others in doing this task. Okay, so good luck, and I hope you learned something today. Thank you so much. Have a great day.